Hello everyone, today we'll be going through a quick introduction to recursion and what thinking we must take when we want to implement recursion. So here we're going to be thinking about the example of printing a linked list in reverse order using recursion. It's much easier with recursion. We can do it with iteration, but it's a lot more fiddly. We'd need a stack and the like. So we're going to do this with recursion. Now, the steps to implement recursion generally are how do we recurse and what edge cases occur. So we'll deal with the first question, how do we recurse? Well, let's think about this here. So when we call print reverse order on the head, we'll print all the strings of the linked list in reverse order. If we call print reverse order on head next, is going to print the strings in reverse order starting from the second node. That's actually what we want if you think about it, because after we've done that at the end, we just print this first string. So that's how we deal with recursion in this case. This is how we recurse. So we'll just add that into our code, print reverse order, and then print the first string. Now the next question, how do we deal with edge cases? Well, in our case, we'll assume that none of the strings are null, so we won't worry about printing what edge cases occur in printing. So we'll just worry about what happens when we reach the end of the list. So what happens when head is null, and that's passed into print reverse order. Obviously, we just add this little clause at the top here. So if head equals null, return. In other words, do nothing. We need to add that obviously because if head is null and we want to know what head next is, that'll cause errors during runtime. So this should compile. We'll check that it does. Compiles perfectly, and does it work? Yes, we can see it is working. We can see this is in correct order. It's printed out in reverse order.